Hi, this is the Temptive podcast where we explore the latest open source, Linux, and IoT technologies and workflows that enable innovative teams to build products better. Today we have a special guest episode and we have Eystein with us. So we'll be discussing a lot about Eystein's involvement and learn from what he has done so far and his recommendations and have fun so far. So your hosts are Cliff and Kem. And hi, Eystein, how are you?
I'm good. Thanks so much for inviting me, Cam, and good to meet you again.
Same here. So tell us a little bit about yourself and your career so far. I know it is very accomplished, but if you give a sneak peek, we can know what all you have been involved in so far.
Absolutely. So I guess I could start with the educational background. I'm more in the math and cryptography side, actually, some computer science. But I started out being quite curious about cybersecurity. This hacks that were happening. How could they happen? And so I finished my master's around cryptography and then found more interest in computer programming, networking, scalability. And I was fortunate to be an intern in a company at Oslo University in entrepreneurship. And it was called CFEngine. I didn't know much about it at the time, but there was a professor there that had built a tool that was used very widely for configuring servers. So configuration management was, I guess, the domain, or server automation, you could also call it. So I started as an intern there, and then continued as a software developer. And gradually, I consider myself as a co-founder eventually, and we moved over to the US. It was scaled up quite a bit. So I moved from Norway to Silicon Valley, San Francisco Bay Area, to work more on the customer side of things then, so more on the support, technical pre-sales, and eventually over to product management. So in general, I think I'm probably more an engineer at heart. I like to build things, make them work. And we did, I'm still at the same company, by the way. So now it's called Northern Tech. So it's CFEngine was the first product that we created, and we've gone through several iterations. I'm sure many of you have been in startups, and there's ups and downs. So it's been a very interesting journey. I've been in many different roles throughout this journey, and learned quite a lot from both the US and the technology, and so that's where I guess it started. But then I guess I met you as well. Cam,
Yes.
back in 2015, was it? Or
Yes, somewhere around that. Yes. And at that time, you were just starting off with Mender. So I guess so CFEngine was solving one problem, right, in
right.
the ecosystem, and then you were starting off with a totally different area. Well, which is kind of interesting. But so, why did you do Mender? And
Yeah.
uh, how was it from transitioning from CFEngine to like Mender?
Yeah, it was very interesting. Like, it was quite different. So what happened in CFEngine and configuration management is that it became, we knew it very well. We had some big customers, like with 80,000 servers, big banks across the globe. But eventually, this space became a bit more commodified. So, like the server information, and you have cloud coming and containers, and it changed quite substantially the market. So there was still a market there, but we saw kind of that this was not a long-term market that we can like stand on one leg on. So that's when we started to like research. Okay, what else is going on? What other problems are out there? And obviously, we saw IoT embedded devices have been around for a while, but there was quite a lot happening with connectivity there, and so we started to research. Okay, how can we are there some problems there that we can help with given our experience from managing like large scale server infrastructures? And then of course we came across this problem of over the air updates, which is like I guess on a little bit abstract level similar to managing large scale servers. It's just you deploy software to devices at scale. So in embedded and IoT, it can be all kinds of different devices. Unlike servers, they're very standard. But we started by like speaking to embedded developers, hundreds of them, including UChem, who obviously was very knowledgeable and experienced in embedded, being founder of Yocto. So we learn like what are the challenges and in terms of over-the-air updates, which we felt fit our skill set quite well, we also saw that there wasn't really a standard way of doing it. And especially when you started to add connectivity, so there didn't used to be connectivity, so then you could just do it manually, USB stick, or you just send the device or product back to somebody and they would update it. But when you added connectivity, there's another dimension of problems. And when we spoke to all these engineers, the first instinct was to build their own way to update the software. Like you create your own server, web server somewhere, and you find a way to distribute new bits of software to the devices. But so that's kind of the first instinct of this embedded engineers. But nobody would do that twice because they ran into so many problems down the line in terms of maintaining it and security and robustness, like that this didn't break. So I guess the takeaway from all these interviews and discussions that we had in the beginning was that there was for sure a need here because everybody was trying to do this in one way or the other. And the other thing was that nobody were happy with the way it was working. And overall, it felt like there was just this huge waste of resources to reinvent the wheel. So that's when we decided, okay, this is a problem we can help with. It fits our skills, and we can save people time basically and do this the right way. So that's when we decided, I think it was back in 2014 or 15, we decided that we wanted to make an open source solution that everybody could use to update, to deploy new software to IoT devices, and that became Mender.
Yeah, it's interesting. So you've been at it almost 10 years now.
Yeah, it's weird how time flies.
Pretty incredible. Yeah.
Yeah, and that's another thing. Like we also thought it would be a simple problem to solve, but there's always those things you don't know about. Right? So now we're looking in. I've been doing research in automotive, for example, which you also could kind of consider IoT device, but they're doing over-the-air updates in like a car with 100 devices over CAN bus and all kinds of protocols and standards. That's a whole other level of complexity. So I don't think we'll run out of problems to solve even within over-the-air updates.
So what are some of the problems people run into with over-the-air updates, or maybe things people don't think about? I mean, a lot of people think, oh, over-the-air updates, that's easy, we'll add that later.
Right.
But I always approach projects like, you need to solve software update first because that will help your development flow.
Yeah.
It should really be one of the first things you do.
Yeah.
So yeah, just curious what your perspective was. What are some things people don't think about, or ways people get burned, if they don't think this through at the beginning?
Yeah, exactly. So that's the classic that you just have an engineer and then you're just right up against your timeline to release your product. And then, of course, as an engineer, okay, this it will have problems. Like I am not able to do quality work here because of the timelines, right? So then you just put in some quick over-the-air solution to be able to fix those problems after the fact. But um, yeah, so I think there are at least a couple of dimensions. I view them more as quality within quality. So one obvious one is security, and that itself has a lot of different layers. So I think we could probably fill the rest of the time only with security if we wanted to. But making sure that the transport, for example, is authenticated and encrypted between a server and the client, and that nobody can intercept or even see what is going on, and ensuring also that you have robustness, as we call it, or reliability. So this can be we use a A/B approach in Mender, so that the most obvious example of this is if you are in the middle of updating a device and then you unplug the power and you plug it back in. What happens? Does it work, or what's going on? So these are things that you don't think about at the top of your head, maybe when you're just trying to solve this problem immediately. And then the other thing is future product lines. So it's fairly easy to, or I shouldn't say that, but it's easier if you're just looking at updating one specific hardware or product or device, and you don't worry about all the future products or devices you might want to have. So you customize the OTA solution for that. Maybe it's on application level, so you only support Debian packages, for example, or you only support like a specific bootloader or something like that. And that can lead to problems down the line, of course, when you have multiple revisions of the product or new products. So yeah, those I guess are some of the challenges, and yeah. It's quite a lot within what I would say quality. So basically, you have to also make sure that the software works with the hardware you have. Is it compatible? Networking, you have to make sure that you can resume downloads, and maybe you lose connectivity for a few days, and scheduling is another thing. So maintenance windows. So these are things that you will discover over time, but it's not obvious that you need them from the beginning. And then when you look at, and again, like after 3 years, 5 years, how much time you spent on developing this, we can for sure look at that. You would see that you're just able to see the tip of the iceberg here of what you really need in production when you're scaling up and you have more product lines.
So when you go back to say, beginning of Mender and then now, so what are the major milestones that you've seen in terms of like, hey, these are the things we didn't do in version 1, but then we added and so and now here is where we stand. So do you have any like 2 or 3 like major milestones in your journey?
Yeah, that's a good question. So in the beginning, we started out as a fully open source solution that was on-premise. So you had to install it, the server and everything. So I guess, of course, first milestone is releasing that, and we supported Yocto out of the box, but then with support for Yocto meta layers and everything. I think then we went into maybe the second milestone was that we delivered a SaaS service, so you could consume the server as a cloud service. Now, I think around 2/3 of our customers use that, so that was probably something we should have started with instead. But that I think was something new for us as well. Now we have many years of experience with that, so it made the consumption much easier. We are working today more on like advanced environment, let's say, within, for example, in terms of connectivity, we're working on we have already like a gateway, so more on like the environment of the product. What does it look like? In this, let's say, first two milestones, we were primarily focused on like one single IoT device, typically a gateway that could be directly connected to the internet. And we focused on like making sure it was easy to integrate with Yocto, with different boards, and had like the basic security features like signatures and so on. But it was always about one device. Now we're expanding more to more like complex deployments. That's where we are now. So you have, for example, a building with 2,000 devices, and they cannot all be updated at the same time over the same uplink. So we need another component to which we call the Mender gateway to enable network to those other devices that need to be updated inside the building. Maybe they're behind a firewall, and also to cache the OTA. And soon we'll also have a way to update, which we call the orchestrator, to update more complex products like a vehicle, like I mentioned before. Because this one you want to update as a whole, right? So you don't want to update just one device inside one vehicle and another device inside another vehicle, and then you suddenly have this, I don't know, 30,000 different combinations of software inside the vehicles at the fleet level. So that's something we call a Mender orchestrator. So I guess the milestones would be more like simple open source gateway updater in the beginning, then moving more to a easily consumable SaaS service, and now we're working more on complex products, not just individual devices.
Yeah, so it's basically now you have a complex of devices, and then there's a policy that I think you have an orchestrator / gateway, which, okay, that's cool. And you'd mentioned about OSS, right? So open source, and from the very beginning, you basically tried to do open source some portions of a product. So how does that fit into your strategy, or what's your take on that? How does it benefit, challenges from product point of view?
Right. Yeah, it's the foundation of what we do. I believe it's very important both for the business and the product side. And so we use what's called, I think most commonly called the open core business model. So yeah, we have an open source core that can do the basic, like the OTA update, and then we can add, for example, role-based access control of the users. That's a commercial add-on that we have in the enterprise plan. So that's how we've done it since day one. We started with only open source because we only had the core, let's say, but then we added the commercial add-ons on top of it, or commercial features. So I think, like, if I'm more from the product point of view maybe when I'm saying this, but maybe you heard about product-led growth. It's a pretty common way to grow with the user in focus, and I think this fits perfectly with the open core model, where you have engineers and users. They want to solve a problem, but they don't want to talk to a sales guy, right? So if you're you just want to Google it, you find a solution, you try it out easily. Once there's a fit, maybe it's not a fit, but if there's a technical fit, then then you can have commercial discussions if it makes sense later. I think this model is very good. It has worked well for us, and open source is very well aligned with this, I think, through the open core model. So I guess that's one side of it, like kind of like a go-to-market or product development approach. But then there's obviously also in embedded, it's even more important because you have so much fragmentation, and you really, especially in terms of hardware and these lower level bits, which I'm sure you can attest to as well. And I guess is also why you founded Yocto in the beginning there. That you wanted, like, you need a community in order to scale, basically. Like, you have a product you're trying to standardize, but then the lower layers are so different in maybe not for good reasons, but they are just different. And then you need somebody who knows this, and they like what you're doing, and they want to contribute back, or they want to share their skills. That's been really important to us as well. So we have a community forum, you could call it, called Mender Hub, where people contribute integrations to Mender all the time. And if you, again, like going back to the product-led growth example, if you Google, for example, NVIDIA OTA or NXP OTA or something, you would see Mender pretty high on the top, because that's typically what people do in our experience when they're looking for, like, they Google their board and OTA or how to update or something like that, and then community member have made a integration, so it will be one of the top hits. So I think that's, and in general, I think it's just a good thing to do. Like I mentioned in the beginning, there were so many building homegrown, and it's so much waste that way. And so even if you don't have a budget to buy a OTA solution, at least you can get something better for free than building something yourself. So I think that's good in general.
Yeah, very good. Actually, I think one of the things I really see is that, for example, for Mender, and this may be an interesting question from embedded space. Mender used Go language for implementation, and so there is always this battle in where people are trying to see, okay, I'm on a deeply embedded system. Golang doesn't fit in there, or so how do you fight that perception, or is that perception true in your learning so far?
Yeah, developers, I guess the one thing they're most passionate about is programming languages and development environments, code styles, and so on. So that's definitely often like a pretty intense discussions sometimes. Like what are the choices and why did you make those choices? So we've gone through an evolution there as well, actually, pretty recently. So in the beginning, we Golang was pretty new at the time, especially in embedded when we started, and so we had some discussion. There were some trade-offs, and I mean, basically, the advantage of Golang was that it would make the development easier and faster for our side. So obviously, users and community would benefit because you get more features and a better solution in a shorter time. And the advantage of Golang was also that it can be used both on the server and the client side. So it was binary compiled, and or is, I should say, and it had very good web application support. So it was easier to develop in, like, especially when we had like fewer developers that had to be in both ends, like the client and the server. And it was quite portable too. It wasn't too bad. So there are obviously some places where you can't use it, and that's why we started looking into also other languages. So what we did, we released earlier this year, is a C++ client. So we do intend to deprecate the Golang client now and replace it with the C++ one. And I don't think anyone, or we kind of knew that this would happen eventually, but at least it lasted for a while, and we had a good progress in the meanwhile. What triggered it was some specific platform. So I think, like, on embedded, you can probably do like 80% or something, like this famous 80-20 rule with Golang. But then you have some customers that have this more legacy set of hardware that can't support the Golang compiler. And then we also, like I mentioned, we're looking into automotive. There you have QNX, for example, operating system. That's impossible. So we would have to port either the Golang compiler there, or we could write it in C++. And it was actually easier to rewrite it. So, but there's definitely the aspect of familiarity with the language too that I think you alluded a bit to there. That is important. So that was a little bit of a drawback with Golang because it was new to embedded. So it was more difficult to get contributions maybe from the community and they understanding it. So so there are some trade-offs. Obviously, C++, very safe choices in embedded, as you know as well.
Yeah, unsafe languages, but safe choices.
Yeah, exactly. Yeah, that's another thing I forgot to mention. That was, from a security perspective, Golang has some advantages.
Cool. I think so. So there is this concept of platforms, so to speak. Nowadays, people talk about platforms more than anything, right? So Android, iOS, or generally any organization, they basically are building a platform. Perhaps you are doing that too, with Mender. Perhaps it's your SaaS solution you talked about, probably is a platform, and you said that you have a community which is independently porting your solutions to different hardware, to a certain extent. So I think our next question was around like platformization software. Do you think, how do you see it? Like, is it good? Is it bad? Or, is it like you're tying yourself into a long-term kind of a binding or a contract, right? So with products, you can go from product A to B to C, and then, there is a transformation. But with platform, that kind of is stuck. You have to have a gradual transformations and things like that. So what's your take on this concept?
Yeah, it's a very interesting question, and something I've been thinking quite a lot about from a product perspective. There are definitely trade-offs, and it depends a bit, like, as a customer, so if or a user, it depends a bit like what type of user you are, I think. So especially in terms of size of the team and needs for customizability. So we see, so for example, in our space, in terms of OTA, there are what I define a platform. It's a little bit dependent on the person, how you define it. Like, it's a little bit subjective, but I define it more like, what's the problem that this product or platform is solving. So if it's a very broad problem, like you can solve a lot of problems with it, then it's more like a platform. But if it's a very specific narrow problem, it's more a product. So that's loosely how I think about it. But if you're like a startup or one person or just a couple of people, and you're trying to bring a new IoT product to market as fast as possible, you probably are well off with a platform that can do a lot of simple, like cover many needs, but not too much in depth. So, for example, in our space, like doing over-the-air updates and maybe some reporting some data back, and maybe you could even like provide hardware even, and that's integrated with the cloud that is provided by the same platform. So like you have just one thing you buy and you get the hardware, the connectivity, the data, maybe maybe that's the more extreme end, but just to illustrate like how I think about it, that it can be time saving maybe if that's sufficient for you. But then what happens usually as you grow more complexity, or if you look at enterprise, let's say thousands or tens of thousands of employees and more, and we see like a big pushback against vendor lock-in, because they've probably been in that situation before where you're so stuck, like I guess you mentioned, that you can't get away from that vendor. So that's I think the biggest disadvantage in terms of our customer base, at least why they choose Mender. I do not consider Mender a platform, because its core focus is over-the-air updates, and we don't plan. We do have some device management features, like remote terminal, being able to like check if a malfunctioning device, what's going on it, and so on. But we don't plan to expand it more broadly, and we rather focus on integration. So we focus more on building like we try to build more of a portfolio and not so much breadth into the product. So yeah, I'm more a believer in the product, like individual products, and then you pick what you need, and I think that will work better, based on my experience, at least with larger and more complex environments, where you can use the best product that fits your specific needs, because those needs are so complicated that I don't think you can build one platform that can solve all the needs of all these different companies. So from that point of view, we also try to make Mender very customizable and solve OTA really, really well. So we make sure that those use cases, like be it updating operating system or containers or scheduling or resuming or signing updates and delta updates, saving network, we solve all those really, really well, but we don't try to go stray away too much from over-the-air updates. Then we would rather consider building another product. And another thing I wanted to add about lock-in, being this is a really big concern, and open source also helps with that. So that's one. I think maybe the primary differentiator or value that our customers see is that Mender doesn't lock them in to anything. They choose to use Mender because and buy the features because they want to, rather.
Yeah, that's it's a good description of the trade-offs. So I appreciate that. So as you look at the technology landscape and there's continually new things coming out all the time. Is there anything that you see as noteworthy, or something that you consider exciting, or you think will change our industry?
Yeah, I since the beginning, and since I started getting into at least more embedded, I came more from the cloud or server side. I was a little bit shocked by the amount of customization that was going on. So it's maybe a bit, but and in many times for reason that doesn't quite make sense to me. Why the bootloaders need to be proprietary and be different for every vendor, or customized like that. Like what?
Yeah, it's endless pain, isn't it?
Yeah, actually, I guess everybody's complaining about that. But so like from a business perspective, like just in terms of time and money that we overall spend on this as an industry, it just didn't make sense to me. But I realized like it was just like that. Like that's the way it's always been. But what I think is bound to happen is that this will standardize, because that's what the customers want. But I think there is quite a bit of tension there between vendors, because they want to, for example, in terms of hardware, they want to differentiate, right? So they want to be unique and try to make something that makes them unique, and not become a commodity. And I guess like every business, that's kind of natural that you don't want to be commodified. But I think that's the tension. The customer wants to avoid lock-in and to be able to switch and to have lower costs, where the vendors are more focused on differentiation that in some cases at least doesn't quite make sense. So I think this will change, but I thought it would have changed more by now when I started. But I see some initiative like ARM System Ready. I don't know if you've you looked into that. Yeah, I assumed you knew that pretty well. But and I don't know that in depth, but I did see some of the benefits that it can provide in terms of you can now switch between more like standard operating system, let's say, or without having to customize the lower layers so much. So I guess, yeah, I would love to see like more standardization on the lower layers, and a little bit more like the environment cloud or application or app developers are used to, where it doesn't matter so much like what hardware you use, or you can just switch more easily. I think this is also obviously one of the goals of Yocto project as well, that you can have this lower layers separated in different meta layers from the top one. So I was just wishing for more, and I think it will happen, and more support from like the hardware or the lower layers there.
Yeah.
I think that's very well said.
Yeah. One thing, we get involved in the MCU space a little bit, so Zephyr is very exciting to us, where we see a standardization across all the microcontrollers, and software is very portable there. So it's things like this will happen. It'll take time, but
yeah, absolutely.
I think if you adding to that, like System 70 system, actually ARM System Ready is actually quite a good effort, good initiative, where you would see that now they're trying to produce generic ARM64 images, right? Which basically are supposed to boot. The rootfs is supposed to boot across any ARM64 device, which is system ready compliant. That's huge in my opinion, right? So, and we are there already. It may be that it will show up in products in coming few years. And similarly, if you look efforts like OpenSBI in RISC-V community, which is even one level lower, where they're like saying, we basically standardize the bootloader interface. I mean, there is completely like every RISC-V have this open SBI implemented at a very low level, which is quite interesting, as a interface to the operating systems on top as well. So I think, yeah, that's probably right amount of time. Probably they understood that differentiation in those areas, customizations in those areas, probably doesn't serve us as they did probably in the past. So
Exactly. Yeah, and Sapphire is also an interesting one you mentioned, Cliff. That's actually an area we are developing now. So we will have Sapphire support as well in about 6 months. But outside, like if Sapphire didn't exist, I think there's like 300 RTOSes out there or something. So
Yeah.
it's like, good luck to us.
yeah,
Yeah, I think Zephyr is a huge change in that industry, and I can't be more thrilled because it's been a real pleasure to work with. So I'm really excited about that, and it's exciting to hear that you're approaching the update problem for Zephyr because, yeah, I mean any MCU needs updated. So if you can solve that problem, that's great.
Yeah.
yeah. I think Zephyr also has done something where I guess anybody who's a MCU maker will think twice of doing something else, because I think
Mm-hmm.
it's like what Linux did to the to the SBCs or compute, because earlier you would go ahead and write your own operating system willy-nilly. You could, I mean, there was an incentive because the other one was lacking in something, right? So but then Linux kind of like filled in those gaps, and people don't think about it. I mean, of course,
Right.
there are other proprietary operating systems out there which are still around, but if you look from open source perspective, completely, people are now saying, okay, you're building a chip with, and with MMUs. Linux is what they're going to port, right? They don't talk about, oh, we should write a new operating system for this, right?
Exactly.
And Zephyr is the same, I would think, for the MCU market, where it is headed towards. Like, any MCU out there, they'll say, oh, software-wise, we gotta get Zephyr on it. That's it.
Exactly.
So
Yeah,
the
we
way,
definitely see more interest in it too
yeah.
now.
So I think the architecture is driven from how Linux kernel was developed, in terms of ports and all that, and the HAL concept is very strong. So I see that quite a promise is there, for adoption across different kind of MCUs segments.
Yeah, and I wanted to tie in a little bit to your question around platform as well, because Sapphire is a product, right? It's not a platform. It's something. It's an RTOS. That's what it does, right? But then you have also these cloud providers like Amazon and Microsoft. They have their own RTOS, so that's more like this big platform solution. So Sapphire, like Mender and Linux and other and Yocto, they give you the ability to not be locked into this platform, right? So I see us playing very well together, at least conceptually there.
Cool. So I think quite interesting, your journey with so far. So, any young, the engineers or entrepreneurs, who are listening to us, any advice you have for them who are aspiring, for doing something like you or something different in the same.
Yeah, I'm not sure if I'm wise enough to give good advice, but what have kind of lasted for me is to start to think about first what are you motivated to do? What are you curious about or intrigued about, or what annoys you, or what you're thinking about, or the causes you support? Maybe a little bit deeper questions, like, and then try to develop in those areas. And my mistakes, I guess, in the past is to look at other companies or other people and try to pay attention to what they were doing. But the thing is that you don't know what they are struggling with either. So yeah, I guess that's like more on a fundamental level, like chase something that's interesting, because that will last and that motivates you. and just learn along the way. I think I'm pretty optimistic in the ability for people to learn. I learn in different areas that I've been interested in, and if you are passionate enough about something, you can definitely learn it. I'm pretty optimistic about that. So yeah, I guess that is my generic advice. But maybe I'll have a more specific one once I get a bit wiser.
No, that's
Yeah.
great. I think that's good. So,
Yes.
yeah,
Sometimes we miss the what's in front of us, like in front of us, which is basically your intrinsic motivation. And people start looking for a lot of inspiration outside, and then they don't pay attention to inside what's motivating them. And so this is a really good insight, in fact. So
yeah, and I feel that there's a lot more problems in the world than there are people to solve them. So there's plenty of opportunity for us all, and if we try to solve the same problem someone else is solving, we're probably
Right.
missing out on something. So
exactly.
yeah,
It's easy to get this kind of herd mentality,
Mhm.
which often happens in Silicon Valley. To be honest. But,
yeah. Maybe next time we'll talk about generative AI in Mender, but not this time.
exactly.
Anyway. So thanks, Eystein. I think this was amazing. I'm hoping that people find it enjoyable, and they'll have few bits to pick from here. And I wish you good luck with future for Mender. I think it's pretty exciting what you're up to, and hopefully we'll reconvene at some time. Thank you.
Absolutely. Thanks so much.